So I'm going to introduce him. I have a biography here. Brother Guy Consolmagno, S.J., is a native of Detroit, Michigan. Graduating from the University of Detroit Jesuit High School in 1970. He studied planetary sciences at MIT, received his bachelor's degree in 1974 and a master's of science in 1975. And the University of Arizona, where he received his PhD in 1978. As a researcher at Harvard and MIT, served in the U.S. Peace Corps in Kenya, and taught physics at Lafayette College before entering the Jesuit Order in 1989. Since 1993, he has served as an astronomer at the Vatican Observatory and was curator of the Vatican Meteorite Collection until his appointment this year as president of the Vatican Observatory Foundation. Dr. Consolmagno has been elected to governing boards of a number of international scientific organizations, including the International Astronomical Union and the Meteorological Society. In 2006, he served a year as the elected chair of the American Astronomical Society's Division for Planetary Sciences. In 2014, he won that division's Carl Sagan Medal, which he showed in the notice tonight, for excellence in education and public outreach. Along with more than 200 scientific publications, he is the author of 6 popular astronomy books, most notably the best-selling Turn Left at Orion, and Would You Baptize an Extraterrestrial, which is right down here. This is most recently with the co-author, Father Paul Mueller. And he also has an asteroid. Brother Guy.
Thank you. And for that wonderful introduction, I'm going to start by putting things in context. You see the title is Context and Controversy, with a short film about my observatory, so you have an idea of where I'm coming from.
Both science and religion are conversations about the universe. They're ways of learning how we interact with this universe. It's not simply a question of is there a God, but there is a God, now what do we do? It's not just a question of there are a bunch of stars, but rather, why are there stars? How do they work? How does that tell us how things work here on Earth? The interaction that I see in my own life is that religion gives me the reason to do the science.
Back in the papacy before Francis was Benedict, and one of his lines in a final elocution to the fathers of the General Congregation was, "Go to the frontiers." Well, there isn't much more frontier than 3.7 billion years away.
The first official interest of the Church for astronomy started in 1582 with the reform of the calendar. Then in 1891, Pope Leo XIII wanted to have an observatory to show that the Church is not against science, but the Church promotes good science.
They start out by having telescopes on the Tower of the Winds, and then on the walls surrounding the Vatican, as the city lights grow, and as the Italian government gives them back the territory up in Castel Gandolfo. In the 30s, they built new telescopes on the roof of the Papal Palace in Castel Gandolfo. Best telescopes of their era in the 1930s. By the 1980s, light pollution makes those telescopes unusable, so we built a new telescope in the dark skies of Arizona.
I'm Father Jean-Baptiste Kikoya Eluo. I'm working in 3 projects. The first one is NEOS, Near Earth Object. So what I'm doing with the NEOS is just observe them using our modern telescope VAT. The second project is meteors. So I worked on very faint meteors, what we call shooting stars. And the third project is a set firewall network. They will have 4 cameras here around the Tucson, so that actually we can monitor any fireball getting into the Earth atmosphere in the region.
This telescope, the Vatican Advanced Technology Telescope, it was the first of the new technology telescopes that has been considered pretty much the norm now in developing telescopes. With the advance of computer technology, we have the capability of bringing that advanced technology directly into our telescope. So it's an expandable, it's almost like it's a living machine, so it can grow as technology grows.
It is still very important to maintain scientific research of the Vatican, simply because there is still a lot of confusion about this relationship between science and faith. We are not out here trying to prove the existence of God by looking through a telescope. That's not what we're doing. But we can say that if we want to obtain any reasonable results looking through that telescope, we need to do it embracing a certain work ethics that is, in fact, the same work ethics that the Bible itself tells us through commandments and through the Gospels to embrace.
Human beings look at the stars and wonder. They want to know, what is that? What is that about? How do I fit in? They hear about the moon landing and they want to know, what was that work? If we're part of the human race, we're part of the race that went to the moon. We're part of the species that looked at the stars and wondered, what the heck are those things? Looking at the sky reminds you that there's more to the universe than what's for lunch. What's more, if you believe in a universe that God so loved that he sent his son, then not only are you going to want to study the universe because it's kind of cool, it's an act of worship. It's an act of getting closer to the Creator and getting closer to a universe, as St. Athanasius said 1,500 years ago, was cleansed and quickened by the Incarnation. Then, doing science is an act of worship.
So you see there's quite a lot of astronomy, a lot of science being supported by the Catholic Church today, and has been historically. So what about Galileo? How does that fit in? The whole Galileo story is fascinating. If you wanted to have it in a nutshell, there's seats down in the front where people are standing in the back. Feel free. A lot of seats in the front. I know you're Catholics and you don't want to sit in the front. If you want the shorthand version of what happened to Galileo and what I'm trying to tell you is that everything you know about Galileo is wrong, but if you knew the truth, the church does not look any better. I'm not here to defend the indefensible. I'm here to ask what happened and what can we learn about it in the context of the time and the questions that were being addressed by Galileo and by the people who were affected. We start with this picture, a contemporary picture of Galileo from one of his books. And notice the way he is described. Galileo Galilei, Galileo, son of Galileo, his father was a musician. Linnaeus, what is that last word? He belonged to an outfit called the Academy of the Lynxes, because the lynx was supposed to have very sharp eyes, and these were people who could look very clearly and see what was going on. And he was phenomenally proud to be a member of this group, that he even uses it in his name whenever he publishes. It's a validation of who he was, which was, I think, very important to him because what he was, among other things, was a college dropout. Then below it says, philosopher and mathematician. Well, that sounds pretty good. Until you realize that in those days, that was one was the exact opposite of the other. A philosopher was worried about the nature of the way things are. A mathematician was worried about calculating useful calculations to try to describe how things were working. Oh dear. And the fact that Galileo was both is a key to the controversy. Aristotle, of course, was the scientist of his day, and Aristotle had a point to say that you should not use mathematics to describe nature, which sounds very odd to anybody who did science today. But he had a point, because he was reacting against the Pythagoreans, who thought that you could use magic numbers to describe everything. And they would, rather than picture where the planets actually were, they would say, well, nature is beautiful, therefore there should be some simple mathematical relationship to where the planets are. In fact, there isn't. Aristotle was trying to say, no, we should look at nature the way it really is, not the way it ought to be. Galileo, they were afraid, was bringing back the magic number theory. But even before Aristotle, there were other views of the universe. This is a drawing done fairly recently, a few years ago, but trying to illustrate what the view of the universe was in ancient Babylon. And it's the view that's depicted in the opening chapter of Genesis. You have to remember the context of Genesis. The author of writing the first chapter of Genesis is not saying this is the way the universe is. He's saying everybody knows this is the way the universe is. Here's what I'm going to tell you that's new. He was taking the best science of his day 3,000 years ago. And the best science of his day was based on observation, the same observation you can make. What's the universe that you live in? You think the world is round? How often do you actually pay attention to the fact that the world is round in your day-to-day life? Never. The world that we live in is flat, and I'm at the center, and the most important thing is the distance between me and the refrigerator. And if I go outside, I can see overhead, if it's not cloudy, and tonight's a beautiful night, you can see a dome. And you can see dots of light in the dome, which appear to move around you. And in the daytime, you can see bright things like the sun or the moon moving. So presumably, they have their own domes. There were years ago, a couple of years ago, I was giving a talk to a group of Native Americans in Lincoln, Wisconsin, talking about my field of meteoritics. And I say, meteorites are rocks that fall from the sky. And an elderly Indian woman says, which sky? And that was exactly a sensible question if this is your cosmology. Because you can see that the moon moves in front of the sun moves in front of the planets, so there are different skies that each of these objects are moving in. Rain falls out of the sky, so clearly there's rain and hail and snow someplace above there coming through holes in that dome. If you dig a hole, if you look at deep in valleys, you'll see rivers. So clearly there's water below. This was the best science of the day. The new thing in Genesis was, okay, given that everybody knows this is what the universe is, what I'm telling you is, before it existed, God was. And God did it deliberately. See, the Babylonians thought the universe was made by accident. The gods were busy doing other things and they goofed up, and this universe, by mistake, came along. The Genesis writer is saying, no, it was done deliberately, it was done orderly, and every step of the way God says it is good. That's what's new in Genesis. And then chapter 2 has a different creation story, things happening in a different order, because that was written a few hundred years later, and now this is our best idea of what happened, but the same message. It was done deliberately, it was done by God. And then later in the book of Maccabees, which was written hundreds of years later, you've got a totally different idea of the universe and how it was made. But it still says it was made by God. This is the biblical view. This is the view of the classical times from the Greeks up through Aristotle and into the early Renaissance. It says, the earth is at the center and you're surrounded by all of these spheres. Well, actually, no. The earth is not at the center. The earth is at the bottom of the universe. And to show that it's not a privileged place, think of what's underneath the earth. tells you that, that's who the Inferno is. So if you're saying the Earth is special because it's at the center, then you're saying hell is even more special because it's even closer to the center. That's not the way they were thinking. The Earth was at the bottom. Oh, and incidentally, you don't believe that the Inferno is beneath the Earth? I can take you to an island off the coast of Italy called Volcano, and I can show you a hole in the crust that's full of fire and brimstone. I've got the data. All they were doing was describing what they saw. You knew that rocks fall. Water falls, but rocks fall even through water. Air bubbles up even through water. And fire goes up even in air. So clearly there are natural places for the four elements: earth, water, air, and fire. And since there are natural places, there's really only one possible natural place, so this must be the only possible universe. And we, in our corrupt human form, because everything underneath the sphere of the moon wears out and dies, we see the universe this way, but in reality, we're seeing it inside out. Actually, God is at the center, and we are at the farthest reaches, as far away from God as you can get. That was the medieval view. And each of these different spheres were the different spheres of the different planets, moved by planetary intelligences, which would then send messages back and forth through demons. That's where the term demon in your computer programs comes from. It's a thing that sends a message. The other word for demon was genius, and so each planet had its own genius. If you were born when the genius of music was there, then music genius was raining down on you. Other geniuses controlled sleep, so some of you may have been born under the genius of sleep. At the same time, astronomers were mapping the detailed motion of the planets, and you recognize that this is not very good at coming up with the detailed motions of the planets, so you have this instead, which are a bunch of circles and circles within circles and circles within circles within circles, and you notice that this picture is completely different from the spheres, but people believe both at the same time. And both of those pictures are completely different from the biblical picture of the flat earth with the dome. Did people in the Middle Ages who believed in this system worry that this didn't look like the biblical system? Actually, they did. And St. Augustine addresses them in a book he wrote about the year 400 on the literal interpretation of Genesis, where he says, even a non-Christian knows something about the earth, the heavens, the other elements of the world. It is a disgraceful and dangerous thing for an infidel to hear a Christian, presumably giving the meaning of Holy Scripture, talking nonsense about these things. It's St. Augustine. The Church Fathers in Roman times treated everything in the Bible on multiple levels, so that it was meant to be symbolic, it was meant to be allegorical. You can find the writers of that era taking the story of Moses leading people through the desert and saying, that's actually a secret allegory for the life of Christ. It's a perfect match, if you read these people. I'm not quite sure how they make it a perfect match, but they were convinced you could. The allegorical world was the world they lived in. Very different from the world we live in. When Copernicus comes along in publishing this in 1543, you can see that his system, I'll stop for the graph. You can see that his system is not all that different from the Ptolemaic system. All he's done is shifted where the Earth is to a place further out and put the sun. And even the sun is not the exact center. The sun makes a little circular dance because he still has all the planets moving in perfect circles and then circles within circles to account for the fact that the actual motion of the real planets in the sky is not something smooth, but something that sometimes moves back and forth. And they wanted to be able to calculate those motions. The jump between that and that is not nearly as great as the jump between that and the biblical view. But people had no trouble with the biblical view versus this version. except for that one episode you see in St. Augustine. So we come to Galileo. I've said that everything you know about Galileo is wrong. Well, where do you go to find out the truth about Galileo? Amazon.com. Do a little search and see what books they have. They've actually got quite a few books. One of these must have well, actually there's a few more books. Maybe one of these, well, maybe there's a few more books. Actually, the last time I did a search on Galileo biography, I got 400 hits. Every one of them going to tell you the truth about Galileo, and no two of them agreeing with each other. In fact, if you read some of the letters of Galileo after his trial, he doesn't know what happened to him. It's a fascinating mystery. And as a mystery of history, it's not something that's going to be solved at this talk. I'm not going to tell you the whole truth either. Don't believe a word I say. Actually, if you want to look up something, this is my favorite book precisely because he doesn't give you an interpretation. What he does is he takes all the relevant documents, or his choice of relevant documents, what Galileo wrote, what his friends wrote, what his enemies wrote, what Cardinal Bellarmine wrote, a transcript of the trial, which doesn't read at all like you think it's going to read. Most of the trial is Galileo saying, I'm sorry, what can I do to make things better? What do you want me to change? Be happy to change anything. Read it for yourself. And then you can write another book, and there'll be 401 books. Let's do a little bit of lead up to put it into a context. 1453, in some view, the fall of Constantinople, to many people is sort of the beginning of the end of the Middle Ages, the beginning of the Renaissance. Because of that, there is a need to explore other routes to the east to get the spices of the east. That's why Christopher Columbus goes off to America. The rise of the mercantile system in Europe leads to nationalism, leads to Martin Luther. Copernicus is encouraged to write this book by a cardinal. He dedicates it to the Pope. And it's published in 1543. The Council of Trent is called on to deal with Martin Luther and Protestantism right after Copernicus' book. You know what the Council of Trent says about the Copernicus book? Zilch. Doesn't even notice it. Doesn't care less. Galileo was born after the Council of Trent is over. Kepler, the other fellow who actually gives us elliptical orbits, born a little bit later. Now, from here, we're going to go and look into the life of Galileo and all the events from when he publishes his first description of things through a telescope. And it's kind of a long timeline, so I put it into a little bit of a scroll here, but follow carefully. The neutral things are in black. The good things are in blue. The bad things are in red. He publishes, somebody says something nasty, then somebody defends him. Somebody says nasty, defends him, nasty, defends him. And the nasties and the defenses are pretty much evenly spread out. 1615 is kind of a magic moment when he's accused of heresy and is absolved. His great book starts out being written in the 20s. Wonderful blue, wonderful blue, wonderful blue, and suddenly there's a mass of red things that happen. All through 1633. Finally, he's sentenced, and then it ends up with a bunch of blue things again. All right, maybe a few of those went by too fast. So, it'll take a while for this to finally admit that it's finished. There we go. Let's take the key dates. We got over the Copernicus book. Galileo writing a book about the telescope. The letter to the Grand Duchess Christina is a letter that he publishes privately. He doesn't actually publish it because this is where he gives his theology of how you reconcile his new science with religion. A point of view that actually is later endorsed by Pope Leo XIII. But he writes it as a private letter because he's not a licensed theologian, and he can't publish theology without a license. Considering that publishing theology without a license leads to wars in this era, you can understand why people are leery to let this happen. But this is a letter that gets widely circulated and is very controversial. As a result of it, a group of people finally look at the Copernicus book and say, there are dangerous things in this Copernicus book. And so you know what the church orders? The church orders that Copernicus's book, if you've got a copy of Copernicus's book, this is what you must do. You must take that book and find the page and find the line where it says the earth moves around the sun. And you must cross out that line. And right in the margin, we can calculate by pretending the earth moves around the sun. And then go ahead and keep it. A fellow named Owen Gingrich, a historian of science at Harvard, has looked at every extant copy of the first two editions of Copernicus's book. He describes this in a book he calls The Book Nobody Read. And he notes that the ruling that you have to cross this out only applied in Rome itself. The rest of Europe didn't have to follow it, and nobody outside Europe did this. The books that were held in Rome, only half of them are corrected. We at the Vatican Observatory have a third edition of Copernicus, dating from 1617, in our library. It's not corrected. He goes on trial when he writes another book defending Copernicus, and finally, after the trial, he writes his final book on the new physics, which is probably the thing he's most famous for among physicists, where he really introduces the idea of using mathematics in physics. Now, I put 2014 next to the book in the trial. Let's imagine that Galileo is on trial today. What year would it have been when the Copernicus book was said to be corrected? 14 years ago. There's a 14-year gap between when the book is ordered to be corrected and when he writes a new book defending Copernicus. 4 more years before then, when there was this, Galileo called into Bellarmine, and Bellarmine says, okay, you're not a heretic, but stop pushing the Copernicus stuff, it's making people nervous. And that was 5 years after his book first describing the telescope. And all of this is 90 years before the Copernicus book comes out. The first big point to mention is that Galileo was not some outsider who was stomped on the first time he tried to push Copernicanism. He was somebody who was talking about a theory that was almost 70 years old when he first mentions it, who makes a living selling books, including books that are approved by the church, and not just approved, but the official censors say, we in our era will be remembered because Galileo lived among us. Which is actually true. Why did it take 75 years before anybody found a theological problem with Copernicus? Why did Galileo get off with just a warning in 1616? Why did everything go wrong in 1632? And why did he write and publish his most important book after the trial? Those are great questions. I'm not sure that I have answers. I'll suggest a couple of them. But I do want to point out that there are a number of answers you'll find in the textbooks. It was a tragic conflict of worldviews. That's one of the official church lines when they reviewed Galileo in the 1990s. Lovely statement. I'm not quite sure what it means. You'll hear, the church is always afraid of new ideas. Actually, considering how long they lived with Copernicus, that alone I don't think really works. There's one theory that, he actually secretly believed in the atomic theory. You can't make the atomic theory that everything's made out of atoms fit in with the theory of transubstantiation, and therefore he was considered a heretic. Well, considering that the atomic theory was actually proposed by a Jesuit priest 50 years later, and a guy named Bosco He made too many personal enemies. Well, he did make a lot of personal enemies. He's an Italian. That was his style. The philosophers were out to get him. The Jesuits were out to get him. And some of Galileo's letters, he actually writes that he thinks that's what's going on. Maybe. But on the other hand, he actually went out of his way to insult the Jesuits first. So, his book personally insulted the Pope. In one reading of it, it did, yes. But the book was not snuck out without the Pope's knowledge. It was finished 4 years before it was printed. It passed by the Pope's personal censor, who told him, these are the things we want you to change. The Pope, a fellow named Barberini, came from Tuscany, as did Galileo. Galileo tutored the Pope's nephew in mathematics. Galileo was a friend of the Grand Duke of Tuscany. Galileo was a friend of the Pope. Galileo was a member of the Order of the Lynxes, as was the Pope. It's not like they didn't know each other. It's not like he was some outsider being stomped on. He was an insider who thought he was Teflon, who thought he could get away with anything. Because for 20 years he had gotten away with anything. My favorite theory for why it all falls apart in 1632, it's not mine, it's based on work that this fellow wrote in a paper, a history paper. He's a real historian, I'm not, I'm an astronomer. I note, first of all, older treatments often portray Galileo as a partisan of a novel science against the conservative church orthodoxy, but studies of the Galileo Affair written in the last few decades have exploded this older myth that Galileo's condemnation of the conflict between science and faith, or novelty and authority, or rationality and irrationality. The church was supporting astronomy even then. The Council of Trent did talk about astronomy. It said, hey guys, the calendar doesn't work, fix it. And Pope Gregory XIII hired a bunch of astronomers who used Galileo or Copernicus's tables to fix the calendar. The church was involved in astronomy because the church started the university system where astronomy was one of the 4 subjects you had to take before you could get your doctorate in theology or philosophy. The church was involved in astronomy through the Roman College and the Jesuits, who first supported Galileo until he turned on them. So, what is David Marshall Miller's theory? It was the 30 Years' War. The 30 Years' War starts around 1617. It's billed as a conflict between the Catholics and the Protestants. Mostly took place in Germany. Germany in those days is a bunch of little city-states and principalities, and some of them are Catholic, some of them are Protestant, and the rule had been whoever rules gets to determine the religion in that state. Half of the states, well, most of the states, we had electors who could elect the Holy Roman Emperor. The Holy Roman Emperor was being elected by mostly Catholics, but in fact, mostly Spanish. And there was a close personal connection between the Holy Roman Emperor, who was trying to control Germany, and the King of Spain, who's trying to control Germany, and the Spanish Netherlands. It's really Spain against all comers. Now, there are other Catholic countries besides Spain. France didn't like Spain. Very Catholic, is funding the Protestant side. All of the Italian states are looking at the Spanish army that's in the kingdom of the 2 Naples at that point, the 2 Sicilies, including Naples and Sicily. And they're very, very leery. The Pope, Urban VIII, had been elected by the support of French cardinals. So the Spanish are very suspicious of the Pope. In 1632, the Swedish army, you didn't think of the Swedes as being military. But remember, these are the guys who used to be Vikings. So actually, yeah. The Swedish army invades Catholic stronghold of Bavaria, that's southern Germany. The control of the Holy Roman Emperor, which had stretched from the Alps to the Baltic 2 years earlier, was reduced to Austria and Bohemia, and these were defenseless. It looks as if the Catholicism was on the verge of extinction in Germany. Gustavus Adolphus is the king of Sweden, who's leading all these armies. The Swedish invasion of Italy seems imminent. After this battle, in a parade of almost daily audiences, the Spanish party in the imperial representatives in Rome, speaking in Rome, accused Pope Urban of inadequately supporting the Catholic cause and demanded a series of concessions, including sending papal troops. Interesting war if it's Catholicism versus Protestantism, that the Pope hasn't sent any of his armies to help the so-called Catholics. One meeting devolves into a general shouting match, and the Swiss Guard were summoned to restore order. Ever wonder why they were Swiss Guards? Because they were neutral. Because they weren't under the pay of any of the locals. Afterwards, Borgia, who's the representative of the Spanish, has the full text of his complaint published, and as the scandal grew, other Habsburg clients implied the Pope is secretly in league with the Protestants. The Pope is secretly a Protestant. Is the Pope Catholic? They threatened to hold a general council to depose him. This is what's going on in 1632. Okay. The printing of the dialogue is finally completed in Florence. This is in Florence. This is Galileo's book. And about this time, within a month, the Holy Roman Emperor is defeated. Cardinal Borgia attacks the Pope. And a couple of months after that, Munich in southern Germany falls to the Swedes. That summer, Galileo's book comes out. Look at me, I've got this wonderful book about the theories that makes the Pope look silly. The Pope is under serious attack. He decides, I'm not going to let Galileo get away with this, and I'm going to send this on to the Inquisition. In November of that year, the Swedes win again, but Gustavus Adolphus is killed. The wheels of justice grind until 1633. The Galileo trial occurs, and he's found guilty of, originally they're going to say guilty of heresy. Galileo gets up and says, wait a minute, what heresy? You haven't specified any heresy that I'm actually guilty of. So they cross out heresy and they're writing, you are found guilty of vehement suspicion of heresy. Galileo has to read a statement where he recants anything in his writings that are heretical without ever specifying what those things might be. 1633 is a really weird year because the Catholic general who'd been hired by the Holy Roman Emperor to lead his armies, basically he volunteered to pay for the war if he could be the king, or the general. He actually conspires to take over the army and depose the Holy Roman Emperor. And he's killed by the Spanish. Meanwhile, Galileo had been sentenced to house arrest. The Bishop of Siena says, oh, look, my house. Come live with me. You're famous. You tell wonderful dinner time stories. Everybody's going to want to come. This is what Galileo had been living on for 20 years. Finally, in December, the Pope allows Galileo to go home. And he spends the rest of his life under house arrest, originally with limits as to what letters he could write, what letters he can't write. He's trying to tell his friends who are saying, oh, let Galileo go free. Shut up. Don't stir things up anymore. Eventually, he's allowed to have visitors. He's allowed to write letters. He eventually writes the book that makes him famous, the book on the mathematics of physics. And he has it published, not in Rome, but up in Holland, in Protestant Holland, where he doesn't have to go through the same paperwork. But clearly he gets this book, smuggled out. He also writes this when he's pretty much blind. Now, one of the problems that we face when we're trying to evaluate Galileo is that we all know that basically he was right. They didn't know that. What was his evidence that he was right? He had evidence that Venus and Mercury were going around the sun. he had evidence that, you can see that with the telescope, and that things were going around Jupiter, the Aristotelian system doesn't work. But Tycho Brahe, 30 years earlier, who took the best naked eye observations of the positions of planets and was very aware of the Copernican system, had a completely different view. He said the trouble is that data do not allow the Earth to be moving relative to the stars. And he had a different system where the Earth is in the center, the sun goes around the Earth, and all the other planets go around the sun. Now the fascinating thing is that mathematically speaking, this is identical to the Copernican system. You cannot tell the difference by observing planets. The only difference between this system and the Copernican system is that in this system, the stars are going around the Earth, not the Earth going around the sun. Meanwhile, Kepler is coming up with an idea of elliptical orbits, and it's thought, can we actually test this? So cathedrals across Europe are turned into giant solar cameras. This is Cassini doing this in 1655. You put a pinhole in the south wall. This focuses the light of the sun onto a disk on the floor. You can see where the sun is crossing the floor on a meridian stripe. And you can see by how the sun gets bigger or smaller whether or not it's moving in a little epicircle or if it's moving in an ellipse. And so these things were built all over Europe. Among other things, they allowed you to measure the exact latitude and longitude so that you could finally make accurate maps. Cassini did this for the King of France, who then said, thanks to your map, I've lost more territory than I've lost in all of my wars. The trouble is, because of the wave nature of light, you could not measure the size of the sun accurately enough to test whether Kepler or Tycho Brahe was correct. But they were willing to make the measurements to find out. There's a lovely story about these particular paintings. These are paintings that were found in the early 20th century. And you can see there's various people in lovely dress, outdoors, at night, with things up in the sky. What do you do when you come up with a bunch of paintings? Well, you find an art expert and you say, okay, what can you tell us from the style of painting when these were painted? And the art experts say, well, from the clothing, from the way they draw the leaves on the trees, from the style of the mountains. You can pretty much identify this as coming from Venice. I would say 1595. There's a thin crescent, Venus. There's Jupiter with its moons and stripes and a red spot. You can only see those things with a telescope. And the telescope was not invented in 1595, or at least not used to look at the sky. This is 15 years before Galileo's telescope. What's going on? Well, you do a little more research, and you find out, in fact, these were painted in 1711 by a guy who is famous for painting in the style of Venice 1590. And they were painted because there was a young guy, a duke, named the Duke of Bologna, who wasn't yet duke. He was in high school. And he and his high school buddies would get together. I remember when I was a kid, I would draw pictures of the flying lab I would have when I grew up and I was rich and famous. He drew pictures of the astronomical observatory he would build when he finally had the money. And when he turned about 20 or 21, his dad dies. Suddenly he's the new duke. And he writes to his friends, hey, I'm the duke. We can build this now. And of course, the rest of the family says, yeah, not with the family money, you don't. Build it with somebody else's money. Go to the government. Well, Bologna in those days was controlled by the Holy See. So he went and put together a proposal for all the astronomical instruments he wanted to buy. And to make it look like this was a wonderful thing to do, and a very elegant thing to do, he had the most elegant painter of the day illustrate them. This was his PowerPoint show. Where he went and said, these are the instruments I want to buy, and these are the elegant things we're going to do with them. And you can even tell from where the positions of the planets, so yeah, it's 1711. He got the money. The church paid for what is now the oldest extant commercial or civic astronomical observatory that in Bologna. Galileo writes in 1609 about the telescope. Is put on trial in 1633. If you look after 1633, there are a lot of books published in the North, in the South, among Catholics, among Protestants, about whose system is right. It really isn't decided until Isaac Newton writes his laws of physics, which explain mathematically, hey, Galileo had something going, why the Keplerian ellipses, it was Kepler after all, actually do a good job of describing the motions of planets. Newton shows that you get ellipses if you apply his laws of physics and his law of gravity. At that point, you finally have a system that makes sense, and this was first published around 1680, but the final edition doesn't come out until 1730. So it's really about 100 years, 1726, it's nearly 100 years after Galileo before the scientific world finally gets it, that yeah, this was probably right. And it was Roger Boscovich, the atomist guy, who finally convinces the church to say, look, let us teach it as the way things are, as philosophy. Because up until that time, all the schools were teaching the Copernican system as a mathematical way of calculating planets. Now they can teach it as a way of describing how the world actually works. So that you've got things like this painting, which appear in 1760 on the ceiling of a college in Prague, and there are all these lovely angels looking through a telescope at stars, and every star is surrounded by planets and little comets. This is the context of Galileo. Well, what happens to Galileo after his death? Finally, in 1729, James Bradley is able to see the aberration of starlight, which suggests that the Earth is moving. And the Roman Inquisition says that Galileo can have a nice tomb, and the church allows his published works to be published. Boscovich makes sure that there is no ban on teaching the Copernican system, but we're not going to admit we were wrong in saying that the dialogue was dangerous. By the 1820s, somebody points at some arch-conservative and says, hey, look, this guy is teaching Galileo, it's on the index. And the whole audience goes, oh, you're right. Oops, sorry about that. And they quick pretend that it's not on the index anymore. Until finally, Leo XIII basically says Galileo was right all along, not just in his physics, but also in his theology. Another piece of that context, though, in the 19th century is the eternal war between science and religion. The world of Isaac Newton was a mechanical world where the universe was just a giant machine. God made the machine, God starts the machine off, and then sits back and watches. In any place where the machine doesn't work the way that science explains, well, there's God fixing it to make sure it works, and that's why we probably need a God. Until you come up with, well, actually, we don't need God to do that, and we don't need God to do this. There's a famous quip where Laplace has a new theory of orbits that doesn't need God at all. Napoleon says to Laplace, where's God in your theory? And Laplace says, I have no need for that hypothesis. And Laplace is right. He doesn't. Because if all you do is reduce God to a hypothesis, to a natural law next to all the other natural laws, then suddenly it's the god of crops and the god of lightning and the god of thunder, and it's a pagan nature god. And that's not the God that was in Genesis, who was there before the beginning, and who built the world in an orderly way, and said, this is good. I don't need to fix the things that don't work quite right. Very different from God. There is, in the 19th century, the belief, especially in the later half, that there is a war between science and religion. Because, in fact, there is a war between the kings supported by the church, who are pretty much conservative. Always, and, let's not start wars. Wars are generally not good for people, versus those who want revolutions, because the way the world is also not good for people. In the 19th century, you've also got this idea of progress. It's called sometimes the Whig idea. We've got steam engines. We've got electricity. It's only a matter of time before we have flying cars. And as technology grows, as our wisdom grows, as we get smarter, we will solve all human problems. So this is the 19th century. Just imagine how beautiful and how perfect the 20th century is going to be. With advanced technology, we'll have no more wars. We'll have no more diseases. We'll have no more mustard gas. Not only that, but we're clever enough to understand how to make the human race better. By selectively breeding better people, we can make sure that the human race improves itself. And fortunately, God has made it easy to figure out who the better people are. They're the ones who look like me. An awful lot of what we do in science is based on the mathematical analysis of data and the statistical analysis of data, and that was all invented by the eugenics people who are desperately trying to figure out why their theory wasn't working. Because it seems so obvious. Everybody knows the Irish are stupid, especially if you're British, you know that. And we have a perfect reason for why the Irish are stupid. Because all the smart Irishmen become priests and don't have families. That was their theory then. Doesn't work quite like that. When the church spoke out against eugenics, it was accused of being anti-science. Did you ever see the book that was put on trial in Scots trial? You know, the famous anti-evolution trial in the 1920s. Now, evolution is the best description we have for how things work in biology. You know, anybody who wants to know what's going on, you better study what that is. You better know it. But this particular textbook that was being used in high schools basically was supporting eugenics, the sterilization of the unfit, a lot of other things that we would look at today and go, I'm not all that comfortable with that maybe. But that was what was considered the best science of the day. To go along with social Darwinism, I'm rich, you're poor. Obviously, that's a force of nature. It's built into my genes that I'm supposed to be rich and you're supposed to be poor. And it would be a violation of the laws of nature to make you rich or to make me poor. Because things are the way they're supposed to be. It's social Darwinism. When the church spoke out against that, they were accused of being anti-science. In addition, the church was pretty darn arrogant in those days anyway. There was plenty of arrogance to go around. There was a little bit of competition between the German universities that were, you want to take a lesson, you have to pay for each class, versus the church universities that were free. But you don't want to go to those universities, because they're run by a bunch of church people, and they're going to teach you all this outdated, old-fashioned knowledge. We're going to teach you the new good stuff. And then there's Andrew Dixon White and a few other lovely people who said America is being overrun by these inferior people from Southern Europe with vowels at the end of their names, like Consolmagno. And they're all Catholics. And the fact that they're all Catholics means that they're all anti-science. We've got to keep these people out of America. An awful lot of Rick Dixon's book is dedicated to the idea that everything the church ever did was wrong, everything that science does is right, and therefore we have to keep these church people out of the country. It's an anti-immigration scheme. All of these political things are building into the idea in the 19th century that the church is against science. Meanwhile, what are the great inventions of the 19th century? Taking the spectra of stars, done by a Jesuit priest in Rome. And as their national representative, they will send Angelo Secchi, the fellow who invents spectroscopy, to go to national meetings, and when the Italians say, he's not a real representative of a real country, everybody else says, yeah, but he's got better science than you do. So that after his death, Pope Leo XIII wants to show that the Church supports astronomy, also wants to show that the Vatican still is an independent country. The Germans invaded France. The French pulled their army out of Rome to defend Paris. Garibaldi's armies march in, and at this point the Vatican is left to just the area around St. Peter's itself, a couple of acres. And science continues to be done, supported by the Church, by Church people. Three guys in this picture. You recognize the guy with the wild hair on the right. The guy on the left is Millikan, who was at Caltech, which is where this picture was taken. He was the guy with the famous oil drop experiment showed that electrons are individual particles, and was a fundamental step in understanding quantum theory. The guy in the middle with the funny collar, that's a turtleneck, I guess. Georges Lemaitre had a doctorate in mathematics from Louvain, a doctorate in astrophysics from MIT, and as a mathematician, he was able to look over Einstein's theory and read the mathematics as if it was poetry, and recognize that what this was really saying was that the universe was expanding. And if the universe is expanding, then it must have been smaller and denser with the same amount of energy, therefore a higher energy density, therefore hotter, and there must have been a point where we can actually identify a time when the energy was infinite. And that the universe expanded from this initial extremely infinitely high quantum state. He called it the cosmic egg theory. An Englishman who hated this idea because he thought it sounded too much like creation in the Bible made fun of it by calling it the Big Bang theory. The Big Bang theory is invented in 1928 by a Belgian priest. To this day, as you've seen, we do astronomy. To this day, we have popes who will say wonderful things about Copernicus, Galileo, Kepler, and Newton. Thanks to the enthusiasm and faith of many scientists who follow in Galileo's footsteps. Was Galileo a man of faith? His two daughters were nuns. Now, mind you, he didn't marry their mother. He was an Italian Catholic, but yeah. He could have fled Italy. He could have gotten himself smuggled off. He chose not to. He could have written diatribes against the church. He chose not to. His goal was always that the church would be on the side of truth, as he saw it. Some of his arguments turned out weren't right, but it happens that his general picture was right. What lessons can we get from this controversy? Well, the first lesson I want to come up with is religion uses the language of popular culture. It has to explain itself. But the language of popular culture is often different from the language of science. And the language of science and popular culture change, and it's tricky for religion that has managed to figure out a way to express its very, very difficult concepts in a certain bunch of languages to change that language. Taking the quantum leap. Everybody knows what a quantum leap is in this context. We've all heard that phrase, quantum leap. How many physics majors are in this room? How many of you know what a quantum leap is? It is the smallest possible change in nature. It is the change from one atom state to the next atom state. It actually means exactly the opposite of what most people using that popular language want it to mean. The theory of relativity does not mean that everything is relative. Popular language is a very tricky thing to use. And it's a very tricky thing to use trying to express very subtle theological ideas about what the love of God means. But it's the only language we've got. And we shouldn't mistake the language for the truth, because the language will change. The other thing is, of course, to recognize that one of those what everybody knows, like quantum leaps, isn't necessarily true. That what happened to Galileo was not the church stomping on science because it was anti-science. In one reading, the church was doing what it thought it had to do, as any scientific journal today does. If you write a paper and submit it to the journal that I'm the editor of, I don't say, okay, you don't believe this nonsense, I'll publish it. We don't do that. We send it to a referee and say, read this over. Is this guy, and I send it to a second referee. And if the two of you disagree, then I have to figure out, well, these people are kind of worried about when you change this and you change that. And maybe I'm going to have to say, you know, everybody has read this, thought it's nonsense. The Pope says that Galileo's work is nonsense. In fact, the Pope is a member of the same scientific community as Galileo, member of the Academy of the Linces. The Pope actually finished college, unlike Galileo, who couldn't handle the Latin but wound up teaching math. And the Pope knew his metaphysics and theology and had a license to teach that, where Galileo didn't. In his mind, in his eye, in the academia of his day, he was qualified to say, no, this book should not be published. That's one reading of what happened. Another reading is, yeah, the book actually has things the Pope said put in the mouth of a simpleton. And it's written in such a way that nobody reading it is ever going to think this was a balanced argument, because the Copernican side gets all the and the Pope probably had every reason to feel ticked off. Does either of those reasons, or the Pope was worried about his political status and had to make himself look like he was a traditionalist, or maybe even the Pope is worried that the riches of Florence are going to go into supporting the French, because Catherine de' Medici's granddaughter is the regent in Florence at the time. And that money will go to the French, who will support the other side, and the Spanish are on him to make sure that the Florence's money doesn't go to support one side or the other. So by putting his finger on the golden boy of Florence, he's sending a message, and it's this long, maybe that was what's going on. Or maybe it was something totally different. Whatever, though, all of those reasons I've outlined that might be the reason why they went after Galileo, personal animosities, fear that they got the science wrong, political issues involving the war that was happening just at that time. None of those are religious reasons. But the punishment used on Galileo was a religious punishment. That was wrong. That's where the church made its mistake. Whatever the reasons were, if there were for reasons other than theology, and it sure looks like it was for reasons other than theology, then it was a mistake to use its theological authority. The trouble was, Rome at that time was also the head of the church, and the head of a government, and the head of the university system. It had too many hats, and it got those different hats confused. Patron of the arts. All that you see of beautiful Renaissance Rome, and you go there now, from St. Peter's to a lot of the other, it was all supported by Pope Urban. The other Romans said, what the barbarians didn't loot, the Barbarinis did, because Pope Urban the Barbarini spent all of Rome's money building these beautiful things that have been bringing in tourists for the last 400 years. You have to be careful using modern words to describe theological truths, but you don't have to be afraid to. This is the cathedral in Cairn in northern Australia, built about 20 years ago. The stained glass was put in about 10 years ago. It depicts the creation of the universe using images based on Hubble images. And it's very beautiful. And you go in there today, and you're inspired both by the astronomy and by the setting, that this is a cathedral, and this universe is a cathedral. On the other hand, I wonder what people 500 years from now are going to think. Thank you very much.
Before we move on to a question and answer period, I forgot to thank a few people. Did you know that this lecture, bringing Brother Guy here, is co-sponsored by a few different departments? And I'd like to highlight those departments, and I'd like to thank any of those representatives who are here today, beginning with the College of Arts and Sciences. Dean Wolford is here, as well as Associate Dean John Delano. I'd like to thank both of you. You can stand up if you want. But thank you very much for your co-sponsoring of this. The philosophy department here. I don't know if there's any. Thank you very much, Dr. Magnus. Thank you very much for your co-sponsorship of this. I don't know if there are any other philosophy professors here, but thank you, and there are a few. Thank you very much. I sincerely appreciate your co-sponsoring. And also the physics department co-sponsored this. So if there are any professors here from the physics department, and I know that there are some here because they had identified themselves, again, my sincere thank you. Thank you for co-sponsoring this event, as well as my colleagues in career services. But again, we can't put these lectures on without this sort of collaboration, with between the different departments. So thank you. So, question and answers.
Right. I want to make it clear I'm not a historian. I don't claim that I've done original research into the history. But I'm an astronomer who knows how astronomers think, and someone who lives at the Vatican and knows how the Vatican thinks. And from that point of view, I think I had something original. Yeah.
So I understand that you're not a historian of science, but it occurs to me during the course of your talk that there seems to be a question of what is the use of theory. In the modern sense, a theory is useful if it can make predictions. And it seems to me in the history of, for example, computing the date of Easter, that you had a theory that clearly was not working. And so, to the extent that it's an important calculation to do, you have to have some investment in the modern notion of a theory is producing useful predictions. And I was wondering if you could comment on that.
Yeah, one of the issues that comes up, we actually have a whole lovely chapter in this book on Galileo. And all the really cool stuff was written by the co-author, so I can brag on it. Because he is a historian of science, and I'm not. He points out that what was happening at the time of Galileo, in part because of Galileo, was a complete shift in the role of theory, in the nature of what constitutes the kinds of questions that are interesting, and what constitutes the kinds of answers that are satisfactory. Bellarmine says in a letter in 1616 that Galileo can't prove that the Earth is moving. And he's right, Galileo can't prove it. In a sense, what they meant by proof was the sort of proof that a mathematician would have to prove Euclid's, derive things from Euclid's principles. The kind of proof that could never be overturned. That's not what science is, because science is always developing, science is always changing. And things that we assume are true, like conservation of mass, we then have to say, well, it's actually conservation of mass energy. That was a completely foreign idea before Galileo, and certainly during the time of Galileo. And as Galileo is doing stuff that we now recognize as real science, he's doing it without the tools of, this is a useful hypothesis, let's see how far it can take us. This is a useful hypothesis because it predicts, rather than, we're doing this because we want the prediction. And that is a big issue of what's happening to Galileo and why he wasn't understood. But he himself didn't understand that's what was going on. Because, among other things, he wasn't imbued in the old. I think it was probably to his advantage that he was a college dropout. Other questions or comments? Yes, in the back.
This is a little bit of a lighter invited. Would you ever accept an invitation to be a guest on the show The Big Bang Theory?
I haven't been invited yet, but I had an interesting lunch with the producer of that show, who it turns out comes from Detroit, and we know a lot of people in town. He even comes from my neck of the woods in Detroit. And who sent me a nice email when I got to Sagan Mill. So we are in contact with each other. At that same lunch, I met the guy who is the science advisor who's at UCLA. So, I've actually only seen one episode of it because I've been in Europe all this time. But, I don't need to see the TV show. I've seen the original. Other questions? And feel free to open it up to anywhere you want to go about the work we do at the observatory or anything else. Yes? Oh, no, well, I already had you, so let's try you first.
Assuming that the Big Bang Theory is correct, is the notion of the creator essential?
Oh, that's a wonderful question. Assuming the Big Bang Theory is correct, and I'll interpret that as being it's the best description we have now, and 1,000 years from now, whatever description we have will incorporate where we started in the Big Bang Theory. How does the role of God fit into this? A few years ago, Stephen Hawking wrote a book called The Great Design, I think, or something crazy like that. There's so many different books and so many different titles to get who wrote them. But basically he says, look, I can explain the Big Bang as a fluctuation in the quantum gravity field. Therefore, I don't need God to start the universe. The hidden assumption is God is that thing that starts the universe. But I've just shown that gravity is that thing that starts the universe. Therefore, I would say, he's just proved that God is gravity. Which, of course, would explain why Catholics celebrate Mass. You'd be surprised how many audiences don't get the pun. The problem is, do you remember growing up that little game called Mousetrap? Where you had all the different pieces and you make it more and more and more elaborate, and then finally somebody gets to roll the ball and goes and starts holding out. And people want to picture that God is the fellow who starts the ball rolling. But no, in the game, it's one of the players who starts the ball rolling. God is the guy back at the Ideal Toy Company who invented the game. That's the difference. When we speak of creation out of nothing, which comes out of the Book of Maccabees, it's a wonderful saying, by the way, this idea of creation out of nothing, one of the really profound philosophical ideas, theological ideas. You look where it occurs in the Book of Maccabees. It's a mother giving encouragement to her sons who are being tortured by the bad guys. And she says, don't worry about what these bad guys are doing. We are creatures of the God who created everything out of nothing. And just sort of tosses it off. One of the most profound ideas was a mother's encouragement. I like that. My mom could do that. My mom could do that. Anyway, the idea is not that there was a vacuum, because even a vacuum is not nothing. Even a vacuum has the quantum field. Even the vacuum has the laws of physics. And it's not that creation out of nothing occurred at a time, because even time was created. Creation out of nothing is something that, from our point of view, continually and constantly occurs. Through all time, in all space. The fact that existence exists. And philosophically, we know that nothing can explain itself. If there is an explanation to the universe, it has to be from something outside the universe, hence supernatural, which is what supernatural is supposed to mean. Okay, you have a question there.
So in the course of your opening remarks and also in the short video that you showed, it became clear that as light pollution has become a more and more prevalent problem, that you've had to move all around the world. And even in the video, for example, I could see planes passing in front, which must play havoc with sensitive measurements. And so you've talked a lot about the past, but what's the future of observational astronomy from your perspective?
In the short term, we're very active members of the International Dark Sky Association, and we are charter members, which is headquartered in Tucson, and we know the people directly there. And actually, the foundation that I run helps support that foundation. There is hope that we can at least make people aware that an awful lot of the lights we put out there are totally unnecessary and do more harm than good. In the long run, maybe we're going to have to go to the dark side of the moon. The dark side of the moon can really give you there's the old saying about politics based on hopes and politics based on fear. An awful lot of our writing is based on fear. And as happens when you do things based on fear, you wind up making things worse. If you're afraid of bad guys in the night, having bright lights gives you dark shadows where the bad guys can hide. This does not make things better. But this is a message that we have to keep. Pope Benedict had a marvelous analogy. He said light pollution is a symbol of how our own desire for the comforts of modern technology blind us to the reality of human life, of the poor, of the need for recognizing that there are bigger questions than what's for lunch. And I like technology, you know, I wouldn't live without it. I think, I was in the Peace Corps, I think flush toilets are really good. But I have to recognize that every technology comes with a cost. And that you have to very carefully balance the cost versus the benefit. And behind you, yeah.
More than 4,000 worlds have so far been found orbiting other stars. And as you know, some of those are potentially habitable, and NASA will have within its capability in a decade or so the ability to detect whether they are inhabited.
Yep.
My question is, how might we respond to evidence that there is sentient life elsewhere?
The best answer is to read the literature. The literature in this case being science fiction. Because that's where we have played out the thought experiments of all of the different ways. What you find when you read science fiction is that science fiction is never about the future or about alien races. It's always about the guy writing the book. And the time when the book is written. And there is part of your answer, that the way we respond will depend on the time when the encounter is made. A lovely example is Michael Flynn wrote a book called Alfenheim that posits that a group of aliens crashed onto Earth in Germany in the 1300s during the middle of the Black Death. Who is to say that the aliens are going to come here and now to us? I don't know anybody who has both postulated a far future Earth and a first contact in the same book. But that might be fun to look at. Yes, in the back.
It was mentioned in the opening remarks that you're a member of the IAU. And
Yeah.
were you at the Congress in 2006?
I was indeed. I was
How'd you vote?
in fact, let me tell you, it's another chapter of the book. In 1994, I was in the meeting of the Planetary Commission, and they had elected their board of officers. And somebody said, everybody on this board is either Russian or American, because they were the only ones in those days doing space programs. They're different now. They said, we need a European on this commission. And they looked around, and everybody in the room was either Russian or American. And somebody said, you're from the Vatican, that's Europe, get on there. So as the token European, well, what happens in these boards is that you rise, you know, through this one has it, and this one has it, and this one has it. So I happened to be the president the year that the Pluto decision came up, so I was on one of the committees that had to decide it. Every suggestion that I've ever heard outside of that committee, I heard on that committee. Every suggestion for how to define a planet has an obvious problem with it. And some of them are not obvious problems as well. At the end of the day, I voted, and the way I voted was not the way it came out. But I've lived with the new definition since then, and I'm pretty happy with it. it was really nice to be able to teach an astronomy course and say the planets are this, except Pluto, I don't have to say anymore. Before, every time I have to say except. To put it another way, when I talk to kids, back when Pluto thought it was a planet, all of the other planets made fun of it. It had the wrong orbit and the wrong shape, and it was tilted funny, and it just felt really ugly. And then it discovered it was a member of a whole family of like objects. And rather than being an ugly planet, it was a beautiful swan. And it's much happier. And with that, I think I should probably let you guys all go. Thanks a whole lot.